So suppose we have a Boolean logic function. Say we have f equals x prime y plus or the y prime. So say we have something like that, and obviously we have these little dots in here, which are our and symbol. And so DeMorgan's theorem allows us to start manipulating these functions so we can start getting potentially simplified functions, or maybe use the gates that we're asked to use. So there's two different things that we can really do with DeMorgan. We can do the DeMorgan complement, or we can do the DeMorgan equivalent. Um, so that's something that you need to be careful with when you're asked about that. Is what one are you doing? Are you doing the complement or the equivalent? So the thing is that the complement actually requires, or the equivalent requires you to do the complement. So let's start off by just doing the complement of f here using DeMorgan's theorem. So what we need to do is write f prime, because we're taking the complement of f. So that's what this little prime here symbol is. F complement, f naught. And it equals, let's see what we've got here. So DeMorgan's theorem says that if we're taking the complement, we need to invert all of the literals. So we'll start doing that by writing right x, then y naught. Then we're going to have a c naught, have a y. So basically, if it has this little not symbol on here, we don't put it on our inverted one. And if we don't have it, then we do add the symbol here. So the opposite. What you have in your original function is what you get in your complement. And then we swap all of our ands for ors and all of our ors for ands. This right here, the or gate, here will be an or gate. And this one right here, be an and gate. And now here's something that we really have to be careful of, is the way that our order of operations is working in Boolean logic. What we're actually doing, how it's currently written, is we are anding y prime and z prime, and then oring it with x and y, which this isn't the original precedence that we've had in our function. So in order to retain that kind of precedence that we had there, we need to put parentheses around these terms. So now it's this whole term anded with this term here. And so what we've computed here, this is Morgan's complement. And now what we want is we want to get something that is equivalent to this function here, or the DeMorgan equivalent. So just to kind of write it out, we want f, and so what that equals is f prime inverted. We need to invert f prime. And so we could just invert this function here by using the DeMorgan complement, but if we did that, we would arrive at our top function, and that's not something we want to do because we're going to undo all of our hard work. So instead, what we're going to do is we're going to put a big set of parentheses around this function here, and we're going to knot it. So our final function will be x or y prime and z prime plus or y and parentheses. And so now this whole thing here, this is our DeMorgan equivalent. So the reason why you may want to do something like this is we can start to transform our Boolean expression to use the gates that we want it to use. So, for example, we could if we only wanted to use AND gates, we could further apply the DeMorgan complement or the DeMorgan equivalent to say these terms right here. So it's okay for us to find the DeMorgan equivalent of an individual term here. So let's try that for both these terms. The DeMorgan equivalent, first we need to do DeMorgan's complement. So that's going to be, to find our DeMorgan complement, going to be x and y. And then we need to have a prime on our x. And then, so that's our complement. And now to get our equivalent, we need to put parentheses around it and prime it. So now we've got an AND gate in this term. Now let's find this one here. So we need z and y. And this y needs to be primed. Then around this whole thing, we need to invert it. And this has given us, this is the DeMorgan equivalent of this term, and this the DeMorgan equivalent of this term. So now our final thing, we're getting a little crowded here, but our final thing, final expression, now our parentheses here. So we got a big parenthesis, small parenthesis, x not and y and c and y not prime have our prime right here. So this is still equal to f. This term here is still equal to f, but now we're only using ands and nots. Or actually, if you really look at this, AND gate. But this is something that you can use DeMorgan's complement and DeMorgan's equivalent. Start transforming your functions into or to use some gates that you might want to use, or you can use it to potentially simplify circuits. So that is DeMorgan's complement and DeMorgan's equivalent in a nutshell. And remember, the only difference between the complement and the equivalent is this last step right here, where we put parentheses around the whole thing and we invert it. Hopefully this helped you understand complement and the equivalent.